Hey guys, so in this video we're going to be learning about systems of equations. Systems of equations are basically a set of equations where you want to find a common solution. So for instance we have 4x plus 3y equals 17 and 5x plus 2y equals 16. If we rearrange them and graph, we will get a common solution at 2, 3. But our goal is to try and solve systems of equations without graphing them. So in order to do that, we can either use the elimination or substitution method. Elimination is adding or subtracting two equations to get rid of one variable and solving for the other, whereas substitution is rearranging one equation in terms of one variable to substitute into another equation. This video will focus primarily on the elimination method. Okay, let's start off with something simple. We have 3x plus 2y equals 10 and 3x plus y equals 5. So notice how 3x and 3x can be eliminated immediately if we just subtract the two equations. So if we subtract the second equation from the first one, we would get 3x minus 3x is eliminated, 2y minus y is just y, and 10 minus 5 is equal to 5. So now we know that y equals to 5, and to substitute back into we substitute that back into one of the equations to solve for x. So I'm going to substitute y into the first equation, and we get 3x plus 10 is equal to 10, 3x equals 0, and if we divide 0 by 3, we get x equals to 0. So now we know the common solution is 0, 5. But what if we want to solve for x and eliminate y instead? Well, notice how 2y and y are obviously not equal. So in order to solve this, we need to find a common multiple of both. So common multiple of 1y and 2y would just be 2. So since the first one already has a 2y, the second equation needs to be multiplied by a factor of 2 in order to get 2y. So when we multiply by 2, we get the equation 6x plus 2y equals 10. Now we write the first equation underneath to get 3x plus 2y equals 10. And now we can subtract to eliminate for y. We would get 3x equals 0 and x equals 0. And when we substitute into any of these equations, we get 3 times 0 plus 2y equals 10. 3 times 0 is just 0, so 2y equals 10, and y equals 5. So we can clearly see that the common solution is 0, 5 by eliminating either x or y. Let's try another example. If we have 5x plus y equals 11 and 4x plus y equals 7, notice that the y's can simply be eliminated if we subtract the two equations. So let's subtract the two equations and eliminate y to solve for x. If we subtract 5x and 4x, we get x. Y's are eliminated, and 11 minus 7 equals 4. So we know x equals 4, so we plug that back into one of the equations to get 5 times 4 plus y equals 11. 20 plus y equals 11. Subtract 20 on both sides, and y equals negative 9. So the common solution for this system of equations would be 4, negative 9. But let's say we want to eliminate x and solve for y instead. Notice how 4x and 5x and 4x simply can't be eliminated just by subtracting or adding the two equations. So what we need to do is find a common multiple. The least common multiple between 4 and 5 is 20. So we want to try and get 20x. In order to get 20x in the first equation, we would have to multiply by 4. So 4 times 5x plus y equals 11. That gives us 20x plus 4y equals 44. In the second equation, to get 20x, we would have to multiply by 5. So 5 times 4x plus y equals 7. That gives us 20x plus 5y equals 35. Now we write the second equation underneath, which gives us 20x plus 4y equals 44. Subtract the two. The x's cancel out. 5y minus 4y is simply y, and 35 minus 44 is negative 9. So now we plug in negative 9 back into one of the equations. So we get 5x minus 9 equals 11. 5x equals 20, and x equals 4. Now we know the common solution is 4, negative 9. Any way we do it. Let's do some more problems. A restaurant charges $80 for 3 adults and 2 children, and $110 for 4 adults and 3 children. Create a system of equations to represent the situation, then solve to find out how much the restaurant charges for each adult and child. So we'll let x equal the amount each adult pays, so the adult fee, and we'll let y equal the child fee. So the first equation would be 3 adults times the fee, so 3x, plus 2 children times the amount they pay, so 2y, and the total fee is $80. And the second equation is 4 adults, so 4x, plus 3 children, 3y, equals $110. So let's solve for x and eliminate for y. In order to do that, 2y, and 3y have a common multiple of 6, so we would convert the first equation by multiplying by 3. So 3 times 3x plus 2y equals 80 would become 9x plus 6y equals 240. And the second equation, we would multiply by 2 to get 6y. So 2 times 4x plus 3y equals 110, which gives us 8x plus 6y equals 220. Now we can subtract the two equations. So 9x plus 6y equals 240 minus 8x plus 6y equals 220. 9x minus 8x equals x. The 6y's cancel out, and 240 minus 220 is equal to 20. So x equals 20, and we take this value of x, we sub it back in to the first equation to get 3 times 20 plus 2y equals 80. So 60 plus 2y equals 80, 2y equals 20, and y equals 10. So the restaurant would charge $20 for each adult and $10 for each child. A grocery store sells 6 apples and 4 oranges for $24 and 5 apples and 6 oranges for $28. Create a system of equations to represent this situation. Then solve to find how much they charge for each apple and orange. Okay, so first we need to set the variables. Let's let x equal to the cost of each apple and let's let y equal the cost of each orange. So the first equation should be 6 apples, so 6 times the cost of each apple to get the total cost of apples, plus 4 times y to get the total cost of oranges, equals 24, the total cost. And the second equation should be 5x for 5 apples, plus 6 oranges, so 6y, which gives us a total of $28. Now, this time let's solve for y and eliminate x. So notice that x and 5 have a common multiple of 30. So what we need to do the first equation is multiply by 5 to get 30x. So 5 times 6x plus 4y equals 24, which gives us 30x plus 20y equals 120. And in order to get 30x in the second equation, we multiply by 6. So 6 times 5x plus 6y equals 28. That gives us 30x plus 36y, which equals 168. Let's write the first equation underneath, and then we can subtract. Now we can eliminate 30x, and so that gives us 16y equals 48. So when we solve for y, we get y equals 3. Now, in order to get x, we plug 3 back into one of the original equations, either one of these two. So I'm going to do the first one, so 6x plus 4 times 3 equals 24. 6x plus 12 equals 24. 6x equals 12, and x equals 2. So each apple costs $2 and each orange costs $3. Thank you guys for watching. If you would like more practice, there are homework problems in the description below and answer keys as well.